Let's do a problem like this. This is from Newton's Laws chapter, chapter 5. Let's say I have a block here, 8 kilogram, and another block here, 3 kilogram. I'm going to exert a certain force here. The coefficient of static friction here is 0.6. The coefficient of kinetic friction is 0.4. Over here, the coefficient of kinetic static friction is, we can call that point, we can make it anything we want. So let's make this 0.8. Coefficient of kinetic friction is 0.6. So I can make a different coefficient of kinetic friction here, coefficient of static friction, and then different here. I can ask this question here. What should be the minimum force? What is F min so that the block, the 3 kilogram block, does not slide down the 8 kilogram block. I want it to stay there. Okay? So what is F min so that 3 kilogram block stays. So I want it basically to accelerate with the system. Let's add a part B to it. I can say, what if you push with a force 1 Newton more than that, or 2 Newtons, or 5 Newtons more than that? What's going to happen? What if F equals F min plus 5 Newtons? What is A? So here's how we would do it. We would write down the forces on each block. We have the forces on the 8 kilogram block. We have F here. Now, since the 8 kilogram block has to move in order for this to occur, we're going to use the kinetic friction force, mu Kn. Then you have the normal force. Then you have the weight, 8 times 9.8, which is 78.4. Okay, then let's look at the forces on the 3 kilogram block. You have the force of the 8 kilogram block pushing the 3 kilogram block forward with a force, we call that N prime. Then we have the weight of the 3 kilogram block, 29.4. And then then there's got to be a friction force up, which is, which one does it have to be? Well, since we don't want it moving, it's going to be the static friction force. So mu S prime N prime. Now, because there is a friction force on the 3 kilogram block pushing it up, provided by the 8 kilogram block, then the 3 kilogram block pushes the 8 kilogram block down with the same force. So that's easy to forget. You have to include that. So now what are the forces on this? This one is equal to N prime is equal to 3A. There is no other horizontal force. And then mu S prime N prime has to equal 29.4. So let's put that there. What's mu S prime equal to? It was 0.8. So 0.8 times N prime is equal to 29.4. From that, we can calculate what the normal force is. 29.4 divided by 0.8. N prime has to equal 36.75 newtons in order for that to in order for this to equal to that. Therefore, in the horizontal direction, we have N prime is equal to 3A. Therefore, 36.75 equals 3A. You divide them, and you get 12.25. In other words, we already know that in order for this to stand still, and accelerate with the system, it's got to accelerate at a rate of 12.25 meters per second squared. Now you do the forces on the 8 kilogram block. F minus mu kn, mu k is 0.4, minus, now we also have to include the n prime, right? Because the 8 kilogram block is pushing the 3 kilogram block forward, the 3 kilogram block is going to push the 8 kilogram backward. N prime. So these two forces are easy to forget because they are a reaction pair. So N prime and the downward force. So F minus this and minus this is equal to 8A. Okay, so now we have to find the normal force. So we have to do the vertical forces. N is the vertical force up, must equal to the sum of these two. 78.4 plus mu s prime n prime, which was 0.8 times n prime. But we already know mu 0.8 times n prime from here has to equal to the weight of the 3 kilogram block, 29.4. So n is equal to 78.4 plus 29.4. That's going to be 8, 17, 1, 8, 10, 107.8. Now essentially what is that? Well, essentially that's the combined weight of the two blocks. 8 plus 3 is 11 kilogram times 9.8. That's equal to 107.8. So that's what the normal force on this is. It's almost as if the 3 kilogram block is resting on top of the 8 kilogram block. Okay? So now you take that, you put it into here. F minus 0.4 times 107.8 minus n prime, which is 36.75. Okay, this one is coming from here. The n prime is this one. Is equal to 8 times A. A is equal to 12.25. Okay, so now you solve for this. 8 times 12.25 added to, this one goes over there, becomes positive, 36.75, added to this one, 0.4 times 107.8, 177.87. So that's the minimum force, let's write it here, F min 177.87. 177 newtons is the minimum force you need in order for this to stand still. Now, what happens if you push with a force 5 newtons more than that? So let's erase this. Now, what are the forces on the 3 kilogram? There's still going to be an n prime, okay, which we don't know what it is now. There's going to be a friction force F, Fs, but it's no longer going to equal mu Sn. It doesn't have to be equal to its maximum value. It's going to equal to what it needs to equal to balance the weight, which is 29.4. So Fs equals 29.4, and that's it. So we already know what the friction force is. Now, how does this change? Well, the F we already know is going to be 5 newtons greater than this, right? So that's 182.87. This doesn't change at all. It's still 0.4 n. Does the n change? Well, the downward force is 78.4. What is this force? Okay. The n still stays 78.4 plus Fs. Right? So let's erase this here. So n is equal to 78.4 plus Fs, but Fs still is 29.4. Okay? So N is equal to 107.8. So the normal force has not changed. Okay? So now what is the force going to be here?